Hi everyone, my name is Caitlin Joseph. I know we haven't had much chance to interact this semester, this being an online class, but I'm happy to share my work with you, and I'm excited to see what kinds of projects y'all came up with. GIS is such a fun tool, and even if it's difficult at times. So here's my final project. I'm generally interested in how water interacts with our natural and built environments. So naturally, I think a lot about water being where it's, quote, not supposed to be. I think we can all remember the floods that took place last September and the kind of dramatic imagery that came out of that. So for this project, I'm working off the idea that flooding in urban areas will be an increasingly likely phenomenon, especially as the effects of climate change unfold. And when floods occur, it affects how we use space. My research looks at Cuyahoga County, Ohio, where I lived and worked for many years before moving to Philadelphia. For those who don't know, Cuyahoga County is where the city of Cleveland is located. And I wanted to know what type of land uses intersected with areas of projected flooding. I think knowing this allows us to understand what types of infrastructure are in the path of the flood and hopefully might help us plan how to mitigate it. So the data for this analysis comes from two shapefiles I obtained from the Cuyahoga County Open Data Clearinghouse, which is open access, and I very much appreciated that. Both are polygon files with attribute data. The first is a layer that represents parcels of various land uses. The other shows the area that scientists working for the county anticipate becoming inundated within the next 100 years. I don't know exactly how they determined where would be inundated, but I suspect it has to do with a combination of topography and expected water level rise from the lake. So here I just wanted to show you what these two shapefiles look like in their raw form. This is the land use map. As you can see, it has attribute data that describes how the different parcels are used, whether it's residential, commercial, green space, etc. And there are tons of different land uses, but luckily for me, the shapefile narrows it down to 6 broad categories, and that's in the field use groups, which is what I will use to color code my map later on. Here's the floodplain map. For those unfamiliar with Ohio geography, Cuyahoga County sits directly south of Lake Erie, one of the Great Lakes. A major tributary of Lake Erie is the Cuyahoga River, which runs through the downtown of Cleveland. There's also numerous other smaller streams and rivers. So the first order of business for me was to create a map that showed the various land uses that fall in the path of the floodplain. This was rather simple compared to some of the stuff we did for our labs. Essentially, I conducted a select by location for land use parcels that intersect with the floodplain polygon and exported that data into a new file. I then adjusted the symbology of the new shapefile so that the different land uses were visually distinct. Here's my layout. One of the major decisions I had to make was how to color code the various land uses. I wanted them to be visually distinguishable from one another and from the background. I picked the most neutral base map I could, just to provide a bit of visual context so you could see where the lake is, etc. I also wanted to choose colors that were symbolic to the type of land they described, so green space was coded green, etc. I went back and forth a lot with the colors, trying to make the final map look not too busy or disjointed, and y'all can let me know if I succeeded. But by looking at the colors, it's clear that green space and residential areas were pretty commonly in the floodplain. So I became curious, how could I quantify that? The second part of my project was to summarize the area in square miles of each of the land uses on the map. This was also pretty straightforward. I created a new field, which I simply called area, and that measured the area in square miles of each of the polygons. I then used the summary statistics feature to sum up the square miles for each of the land use categories. You can see how I did that in the plan. The summary statistics tool created this table that shows how much each land use in square miles falls within the floodplain. My hypothesis that about residential and green space making up the bulk of the land at risk was confirmed. It's almost twice as much as industrial. And that's it. So I had a lot of fun making the map, and I hope you enjoyed listening. This class has been pretty interesting overall, and I definitely want to play around with GIS some more going forward. But basically, congrats to everyone for making it through the semester, and I hope you all have a great winter break. Cheers.